G'day, Mr. Fitz here. Hope you are well. In this short video, I'm going to show you the process of how we take our STL file and get it prepared for us to 3D print, the very final steps. So we've saved our file as an STL from Inventor. If you're unsure of that, watch my last video. Next, we're going to open a software called Cura, C-U-R-A. It looks like this on your desktop. If it's not on your desktop, then you can search for it using the Start menu on the bottom left of your screen. Type in Cura. So open this up. It will bring up a window which may look similar to mine. Depending on the version you're using, it could be a little bit different. But generally, it should open with this interface, which is actually a simulation of the bed of a 3D printer. Now, generally, for the first time you go on here, it will possibly have a Add Printer task menu that comes up that looks like this. This is the first step of using this program. You need to set the machine that you are going to be 3D printing with. Now, the defaults, Cura is built by the company called Ultimaker, or who make the Ultimaker machines. We don't have Ultimakers just yet at school. So go to Other. Now, the printers that we use are currently called Cocoon Creates, and we don't have this listed down here. The closest machine you'll find is called a Prusa i3. So find Prusa i3, click on it, and go Add Printer. What that does is it sets up the main parameters in this software according to that printer, which is close enough. Okay, let's open our model. So go to Open. We're going to open our STL that we've created. So mine is my widget. It's going to throw it in my area. Now, this you can see is exactly how the machine's going to build my model. For starters, it looks like it's going to build it from the side. Remember that the machine builds this in layers, starting from the bottom and moving up. So one quick thing is to play with this program and use the mouse to navigate. These navigations will be different to Inventor. So right mouse button enables you to rotate. Your middle mouse wheels enable you to scroll in and out. If you click and hold the mouse wheel, you can pan. So one thing you can see is that any area in red is an area that of potential bad quality. So as you can see, this builds in layers. The reds are showing me what we call an undercut, and that's an area where without some support, these will fall down in the model. So the best way to set up your model is to try and print things flat, or consider how the layers are going to be built and how that affects how your model operates. So in this case, I want to rotate my model because I don't want it to sit vertical. I want it to be flat on the bed. Click your model. If you click it, generally the first option is to move it, so you can move the position. It will, by default, it should throw it in the middle of the pad, which is good. I'm going to rotate mine, so you can scale. You shouldn't need to scale, provided that you've got the settings correct in Inventor, but we want to rotate. Click on the axis or the circle that represents the axis you want to rotate from. So in this case, it's the red circle. And I'm going to click and hold and drag it to 90 degrees. Let go and it throws it down. Now I can just click in space and it will deselect. That's looking pretty good. If you're doing text or things like text, it's always good to have those facing up. The reason being is that if I print this the other way around, then the text itself will probably be a high quality, but all the faces below here will be off of the surface of the printer, so they'll likely droop or look poor quality. So try and keep text and details facing up so they're supported. Alright, that's looking good. The geometry looks fine. That's how I want my print to look. Now we need to go through the final steps, which is setting up the material and the print settings. So on the right here, by default, it may look like it has no settings. You can change the profile, the material. So set the material to PLA. It's called polylactic acid is the material that we commonly use. Sometimes we use ABS, but in this case we're going to use PLA, and you can see there's other materials there as well that are available. There are some default profiles. What I want you to always do is to change the setup to custom. So I want to talk you through the settings on the printer and have you set this up for your job. So let's start from the top. Quality, layer height. The machine is going to build this in layers. The thinner the layer, the better the quality. So 0.1 of a millimeter is a very low height, which will give a very high quality. In this case, I want you to, and I'm going to change mine to 0.25 millimeters. That's a pretty medium quality print. Okay, wall thickness, shell, ignore this one. It's not important to change. Just leave those as they are. Infill. This is the density of the areas internally to your model. So all the outsides will print as a wall, but if you've got big open sections or a large chunky model like a big cube, what this will do is it will set how dense it is going to fill it. So it fills it with like a honeycomb structure or a structure inside. If you set this to 100, your model will be 100% solid. Take a lot longer, it will waste a lot of material, and in most cases you do not need to set this at 100%. In our case, we're going to set this to 40%, which is going to be a pretty solid print. That'll give us a pretty reasonable fill, and the part should be strong enough. Material. These settings here are the default for PLA. We can change these if we need to. I'd like you to change the printing temperature to 210. This is the temperature of the head of the machine, or we call it the extruder. So this material melts at about 185 degrees Celsius, and we're going to heat it up a little bit hotter so it flows a little better, which can give us a bit better finish. If you go too high, you're going to cook the material. It's going to burn, it's going to smoke, and you're going to get a very bad result. So make sure you set this according to the material. In this case, 210. Build plate temp, that's the temperature of the base of the printer or the build plate. It preheats that. It needs to be hot, otherwise what happens is the material that you're printing onto it, if it's cold, it will freeze quickly and you won't get very good adhesion either to the bed or to the part itself. 60 is fine, leave it at that. Alright, print speed. This is how fast the machine head moves. I want you to change the print speed to 50, which is how fast it prints. That's millimeters per second as a velocity. The travel speed is how fast it moves when it's not printing. You can bump that down to 80 millimeters a second. Alright, what's next? Cooling. Make sure that's ticked. That cools down the head of the printer, keeps it running smoothly and doesn't overheat. Support, if you can tick this, is really only when you need to build some support. So like I showed you before, if my model is built vertically, then most likely I want to build some support underneath the structure so it doesn't droop and sag. That support material can be removed after we've printed. It's generally like a thinner wafer that just easily peels off. But generally only tick this if you've got a model that really needs some support. That's going to fall over or have some issues. So don't tick that. In this case, my part is flat. It needs no support. Build plate adhesion. The machine can have some settings that it will build a structure under your model to help it stick to the bed. In most cases, we don't have problems with this with these printers, so I change this to none. But you can put in a skirt, a brim, or a raft, and they will take more time, waste more material, and are generally not necessary. So go none if that's an option. If that's not an option, generally go with a skirt. A skirt is the quickest. So none or skirt. The last two parameters here are not relevant to our printer, so just ignore those. Just about there. Last few steps. Double check the size of your print. This here shows the total parameters. So 85 millimeters by 85 by 8.5 mil high is the total size of the print space. Our printers have these specs. So the maximum size we can print is 200 by 200 by 180 as a cube. always best if you finished your work and you've got a small part, chat to a mate, see if you can get some more parts on the plate. So try and make it efficient. We're always best to print more than one part. So in my case, I could print another one of mine if I want to print 2. As you can see, it throws them out into the middle. I'll have to reorientate and move them. It'll generally move them so they're not clashing. If you try and make them clash, they'll just sort of push out the way. So my suggestion is, before you go ahead, if you can fit it, try and fit some more work on the plate so it is more efficient. So do that. Over here is a time indication. This will tell you an estimate of how long it will take to print. In this case, it's 1 hour and 56 minutes to print 2. If I delete one, you'll see it's how long? 58 minutes, so an hour. So there's a bit of time saved by printing 2 rather than 1. Plus you have to do 2 setups. So you're best to print multiple if you can. You can also have a look at how this varies when you change the settings. So if you change the layer height, it will substantially change the time. So it's a good little indicator. And if you want to do a quick print, you can bump up the layer height to 0.4. That will make it half the time. Whereas you go 0.005, it's going to take 4.5 hours to print it. So that's not good. Let's go 0.25. Cool. All right. Last thing we're going to do here is you're going to save your file onto an SD card. Now, an SD card, if you haven't seen one in a while, looks like this. So for our computers, you're going to need to get an adapter. Mr. Fitz should have one of these kicking around, but you can plug your SD into the adapter and then into a USB so your computer can save to it. Our 3D printers read from an SD card, so you need to save your file onto the SD. So put it into your adapter. Your last step here is to click down the bottom and go Save to File. And go Save to File. Again, tell it where you want it to go. This is onto my F drive, which is my little SD card. Save. And it will save it as what we call a G-code. G-code is the format that the printer uses to build the layers. Cool, now we're done. The very last thing we can do, if you're interested, is to check your file. What this is a G-code file, and it is basically a text file. Every single line of what we call G-code is simply a coordinate system, so an X and a Y and a height as well to tell the printing head where to go. So very simple, and that's all the machine needs. A few coordinates and it's happy. Cool. Once it's saved onto your little SD card, you can take it to see Mr. Fitz and you can put it in a machine, and I can show you that last step to start off the print. And you're done. Just one word of warning, very, very important that you set up your print as per these parameters here. Do not vary these other than what I tell you to do. Problem you can have is you can destroy the machine. The machines are expensive. You can burn the material. You can cause a lot of damage if you put in the wrong parameters. So make sure you follow these closely and see Mr. Fitz to help you set up your print. That's it from me. All the best with your print. If you have any troubles, always come see me first before you start printing. Cool. All the best. Cheers.